Hello everyone, I'm Shai Almog. It's great to be here for HashiTalk to talk about debugging your production Nomad agents using continuous observability. But first, a few things about me. I was a consultant for over a decade, worked at Sun, founded a couple of companies, wrote a couple of books. I wrote a lot of open source code and currently work as a developer advocate for Lightrun. My email and Twitter accounts are listed here, so feel free to write to me. I have a blog that talks about debugging and production issues at talktotheduck.dev. It would be great if you check it out and let me know what you think. I love APMs. They're absolutely wonderful. I'm old enough to remember a time where they weren't around, and I'm just so happy we moved past that. This is absolutely amazing. The dashboard, the details. We're truly at a golden age of monitoring. Hell, when I started, we used to monitor the server by going over there and kicking it to see if the hard drive was spinning properly. Today, with Nomad, the deployments are scaled to such a level that we need tools like this to get some insight into our production. Without an APM, we're, well, not blind as a bat, but it's pretty close. A lot of the issues we run into start when we notice an anomaly in the dashboard. We see a spike of failures or something that performs a bit too slow. The APM is amazing in showing those hiccups, but this is where it stops. It can tell us that a web service performed badly or failed. It can't tell us why. It can't point at a line of code. So let's stop for a second and talk about a different line, this line. On the one side, we have developers. On the other side, we have ops or DevOps. This is a line we've had for a long time. It's something we drew out of necessity because when developers were given access to production, well, I don't want to be too dramatic, but when developers got access to production, it didn't end well. This was literally the situation not too long ago. Yes, we had sysadmins, but the whole process used to be a mess. That was no good. We need a better solution than this hard separation because the ops guys don't necessarily know how to solve problems made by the developers. They know how to solve ops problems. So when a Nomad agent has a problem and the DevOps don't know how to fix it, well, it starts a problematic feedback loop of test, deploy, rinse, repeat. This isn't ideal. Monitoring tools are like the bat signal. They come up and we, the developers, we're Batman or Batwoman, Batperson, all heroes in those cases. We step up and deal with the bugs. We're the last line of defense against their villainy. Code bad people. It's kind of the same thing, just without the six-pack abs, too many baked goods in the kitchen. Code Batman needs to know where the crime or bugs are happening in the code. So these dashboards point us toward the crime we have to fight in our system. But here's where things get hard. We start digging into logs, trying to find the problem. The dashboard sent us into a general direction like performance problem or high error rates, but now we need to jump into the logs and hope we can find something there that will somehow explain the problem we're seeing. That's like going from a jet engine back to Stone Age tools. There are many log processing platforms that do an amazing job at processing these logs and finding the gold within them. But even then, it's a needle in a haystack. That's the good outcome. When a log is already there, just waiting for us. But obviously, we can't have logging all over the place. Our billing would go through the roof and our performance will tank. Well, we're stuck in this loop of add a new log, go through CI/CD, which includes the QA cycle and everything. This can take hours at best. Then reproduce the issue in production server with your fingers crossed and try to analyze what went on. Hopefully you found the issue, because if not, it's effectively rinse, repeat for the whole process. In the meantime, you still have a bug in production and developers are wasting their time. There just has to be a better way. It's 2022 and logs are the way we solve bugs in this day and age. Don't get me wrong, I love logs. And today's logs are totally different from what we had even 10 years ago. But you need to know about your problems in advance for a log to work. The problem is, I'm not clairvoyant. When I write code, I can't tell what bugs or problems the code will have before the code is written. I'm in the same boat as you are. The bug doesn't exist yet. So I'm faced with the dilemma of whether to log something. This is kind of like the dilemma of writing comments. Does this make the code look noisy or stupid? Or will I find this useful at 2 a.m. when everything isn't working and I want to rip out the few strands of hair I still have left because of the damn production problem? Debuggers are amazing. They let us set breakpoints, see call stacks, inspect variables, and more. If only we could do the same thing for production systems. But debuggers weren't designed for this. They're very insecure when debugging remotely. They can block your server while sending debug commands remotely. A small mistake, such as an expensive condition, can literally destroy your server. I might be repeating an urban legend here, but 20 or so years ago, I heard a story about a guy who was debugging a railed system located on a cliff. He stopped at a breakpoint during debugging, and the multi-million-dollar hardware fell into the sea because it didn't receive the stop command. Again, I don't know if it's a true story, but it's plausible. Debuggers weren't really designed for these situations. Worse, debuggers are limited to one server. If you have a cluster with multiple machines, the problem can manifest on one machine always, or might manifest on a random machine. We can't rely on pure luck. If I have multiple servers with multiple languages, platforms, crossing from one to another with a debugger, well, it's possible in theory, but I can't even imagine it in reality. I also want to revisit this slide because I do love APMs, and looking at their dashboard does give me that type of joy we get from seeing a result of work plotted out as a graph. I feel there should be a German word to describe that sort of enjoyment. But here's the thing, APMs aren't one thing. The more you instrument, the more you have runtime overhead. The more you have runtime overhead, the more hosts or agents you need to handle the same amount of tasks. The more agents you need to handle the same amount of tasks, the more problems you have, and they become more complex. I feel Schrödinger should deliver the next line. By observing, we effectively change some of the outcome. An APM needs to observe everything. An APM doesn't know what it's looking for. Like I said before, it's a bat signal or a check engine light. It's got sensors all over the place, and it needs to receive information from these sensors. Some sensors have almost no overhead, but some can impact the observed application noticeably. Some people use that as an excuse to avoid APMs, which I feel is like throwing away the baby with the bathwater. We need APMs. We can't manage at scale without them, but we need to tune them, and observing everything isn't an option. Thankfully, pretty much every APM vendor knows that, and they all let us tune the ratio of observability to performance so we can get a good result. Unfortunately, that means we get less data. Couple that with the reduction of logs that we need to do for the same reason, and the bad problems we have in production just got a whole lot worse. So let's take the Batman metaphor all the way. We need a team up. We need some help on the servers, especially in a clustered polyglot environment where the issue can appear on one Nomad agent, move to the next, etc. So you remember this slide. We need some way to go through that line, not to remove it. We like that line, it's a good line. We need a way to connect the server with the server and debug it. Now, I'm a developer, so I try to stay away from management buzzwords, but the word for this is shift left. It essentially means we're letting the developers and QA get back some of the access we used to have into the ops without demolishing the gains we had in security and stability. We love the ops people and we need them. So this is about helping them keep everything running smoothly in production without stepping on their toes or breaking their deployment. This leads here. What if you could connect your server as a debug agent that would make sure you don't overload the server and don't make a mistake like setting a breakpoint or something like that? That's what continuous observability does. Continuous observability is a complementary to the APM. It works very differently. Before we go on, I'd like to explain what's continuous observability. Observability is defined as the ability to understand how your system works on the inside without shipping new code. The without shipping new code portion is key. But what's continuous observability? With continuous observability, we don't ship new code either, but we can ask questions about the code. Normal observability works by instrumenting everything and receiving information. With continuous observability, we flip that. We ask questions and instrument based on the questions. So how does that work in practice? Each tool in this field is different. I'll explain the Lightron architecture since that's what I'm familiar with, and I'll try to qualify where it differs from other tools. In Lightron, we use a native IDE plugin to VS Code or JetBrains IDEs such as IntelliJ, PyCharm, WebStorm, etc. We can also use a command line tool. Other tools sometimes have a web interface or a CLI only. This client lets us interact with the Lightron server. This hides the actual production environment. Developers don't get access to the production area, which is still the purview of DevOps. The management server sends everything to the agent, which is installed on your production or staging servers. This is pretty standard for all continuous observability solutions. The agent is just a small runtime you add to your production or staging server. It's very low overhead and it implements the debugging logic. Finally, everything is piped through the server back to your IDE directly, so as a developer, you can keep working in the IDE without leaving your comfort zone. Okay, that should raise the vendor alert here. I heard that stuff before, right? APMs have been around forever and have been optimized. How can a new tool claim to have lower overhead than the established and proven solution? As I said before, APMs look at everything. Continuous observability tool is surgical. That means that when an APM raises an interesting issue, we can then look at that very specific thing like a line of code. When continuous observability solution isn't running, its overhead is almost nothing. It literally does nothing other than check whether we need it. It doesn't report anything and it's practically idle. When we do need it, we need more data than an APM does, but we get it from a specific area of the code. So there is an overhead, but because it only impacts one area of the code, it's tiny. This is the obvious question. What if I look at code that gets invoked a lot? As I said, continuous observability gets even more data than an APM does. This can bring down the system and, well, we could end up here. So this is where continuous observability tools differ. Some tools provide the ability to throttle expensive operations and only show you some of the information. This is a very big deal in high volume requests. I think these things are best shown in a demo because I can talk your ears off, but showing a quick demo can explain this faster. I use Kotlin for this demo, but this applies to other languages as well. To start, we need to sign up for a free Lightron account at lightron.com/free. Notice that Lightron has a very generous free tier you can use to experiment with the product. Pretty much everything I show here can be accomplished entirely with a free account. I'll skip the actual setup since it's covered there and we don't have that much time. However, it's important I cover the Nomad integration. So next, we need to connect the Lightron agent into the individual Nomad agents. For the Java code, we can use the Lightron driver for Nomad. This is explained in the docs, so I'll just touch it briefly. In general, the Lightron Java driver accepts all configuration options of the regular Nomad Java driver. To get the driver working, we need to download the Lightron driver repository, find the Lightron Java driver in the repository root folder, copy the driver to your Nomad plugin directory. Then running the Nomad's agent, we need to specify the path to the plugin directory. The Lightron Java driver accepts all configuration options of the Nomad Java driver. We just need to add Lightron Java as a driver to our job file. Then we need to set the secret that we got from Lightron administration server. That does it for the Java driver. We don't yet have integrations for Node and Python, but the integrations there are simpler since they can be done in the code level and you don't need a driver like you do in the Java portion. So you can just follow the instructions on the website and that should work. Obviously, this will work for Kotlin, Scala, etc. This is the prime main app in Kotlin. It simply loops over numbers and checks if they are a prime number. It sleeps for 10 milliseconds, so it won't completely demolish the CPU. But other than that, it's a pretty simple application. It just counts the number of primes it finds along the way and prints out the results at the end. We use this code a lot when debugging since it's CPU intensive and yet very simple. In this case, we would like to observe the variable I. which is the value we're evaluating here, and print out CNT, which represents the number of primes we found so far. The simplest tool we have is the ability to inject a log into the application. We can also inject a snapshot or add a metric. I'll discuss those soon enough. Notice that logs that you inject are all ingested like all the other logs in the system by default. So if you're using Elastic or something like that, they will go there like the rest of your logs. This is pretty seamless. Selecting a log opens up the UI to enter a new log. I can write more than just text in the curly braces. I can include any expression I want, such as the value of the variables that are included in this expression. I can also invoke methods and do all sorts of things. But here's the thing. If I invoke a method that's too computationally intensive, or if I invoke a method that changes the application state, the log won't be added. I'll get an error. After clicking OK, we see the log appearing above the line in the IDE. Notice that this behavior is specific to IntelliJ or JetBrains IDEs. In Visual Studio Code, it will show a marker on the side. Once the log is hit, we'll see logs appear in batches. Notice I chose to pipe logs into the IDE for convenience, but there's a lot more I can do with them, as I mentioned before. For now, the thing that I want to focus on is the last line. Notice that the log point is paused due to high core rate. That means that additional logs won't show for a short amount of time. Since logging exceeded the threshold of CPU usage, this can happen quickly or slowly depending on how you're observing. That's a relatively simple demo to whet your appetite. Let's pull out the big demo guns. So I decided to take on Netflix and build my own movie service. Seems easy enough, right? Well, turns out that isn't the case. Those people on Netflix sure know how to build an application, and this is rough. So I'm terrible at front end. So I hired a developer to build it in React. He also built a Node.js server, which was pretty intuitive for a front-end system. This is basically a pretty sensible architecture. It lets the front-end developer handle all of their stuff, including the start of the back-end area. Node.js scales reasonably well and can handle the stuff it's good at, communicating with the UI, front-end, etc. Node.js is very intuitive for that developer, and that's why he chose it. Storage transactions and reliability are a decade ahead in the world of Java. So using Spring Boot for the backend heavy lifting also makes a lot of sense. I know it well, I built a lot of stuff with it. This is a merge of the best of both worlds. I don't need to do front end, and I can just write the backend stuff that I like. Great, everyone's happy. The problem starts when we need to debug this, especially in production. Finding the source of bugs is a process of digging through logs of different conventions and sometimes even different terms for the same thing. And the problem is we have bugs. So here's the app that will take over the world. As you can see, I have a list of movies in a UI that reminds us a bit of those guys who, again, are doing a pretty spectacular job there. I can add a movie to my list. I can visit my list and see the movies within it. I can open a specific movie and see details about it. That's pretty much it. So here I'm opening Clifford, and now I'm going to click on No Time to Die. But here's the weird thing. When I click No Time to Die, what I get is red notice instead. Fine movie too, but it's a weird bug, and I have no idea why it would happen. I think we can debug this using Lightroom. This is the Node.js project that implements the initial backend of our architecture. This is the method that gets invoked when we click a movie and want to see the details. This time I'll add a snapshot. Some other continuous observability tools call this a capture or a non-breaking breakpoint, which to me sounds weird, but the idea is usually the same. Once I press OK, the camera button appears on the left, indicating the location of the snapshot, like you would see in a regular IDE breakpoint. Now let's go back to the browser for a second, and in the browser I click the movie again to reproduce the issue, and wait a few seconds for the problem to reproduce. Now we need to go back to the IDE. And now we wait a second and the snapshot is hit. So what is the snapshot? It gives us a stack trace and variables just like a regular breakpoint that we all know and love. Yeah. But it doesn't stop at that point. So your server won't get stuck waiting for the step over. Now, obviously, you can't step over the code, so you need to step by individual snapshots. But this is just a huge benefit, especially in production scenarios. So what do we see here? We see the ID of the movie, and it seems like the right ID. So this isn't a case of a bad ID passing from the UI. We need to dig deeper into the Spring Boot server. In the Spring Boot server code, we've got the fetch movie details method, which does the actual fetching. I place a snapshot here, and I'll spare you the pain of doing the web refresh every time. I have a crawl command that performs their request, so I'm running it in a different window here, and as it's not really interesting. So now we need to wait for the snapshot to get hit. If this seems to take too long, spoiler, it never gets hit. And the reason for that is that cache by annotation you see right here above the method. It seems the response from the method is cached. Unfortunately, we can't rely on guesses. We need to verify. So we need to go to the movie manager, which is our REST controller. It handles all the web requests directly. So here we can add another snapshot. And again, to trigger the curl script with the hope that this time we get it right and the snapshot will get hit. After a bit of waiting, we finally hit the snapshot and the get method. This means that our request is happening, but the failure we're seeing is because the cache got corrupted with bad data. Why would that happen, and can we continue our investigation? Well, yes, we can. The place where the cache might be corrupted is here. In check for file updates. This method runs periodically every 60 seconds and checks for the file system for an import file. This is how we add new movies into the system. We place a file with data and it imports it into the database. It might break existing movies. So let's create a snapshot here, and while we wait for a minute for the snapshot to hit, we can use that time productively to delete the no longer used snapshots from before. They will eventually expire, but they're left here in case you need to reference one of them. One of the nice things about debugging with snapshots is that normally you don't have to wait. You can just place them all over the code and they get hit at some point. You can just go get yourself a cup of coffee. You don't need to be next to the computer. So great, the snapshot got hit just in time, so that means this code is working. Now all I need to do is evict the cache with a dummy file and we're done. Or are we? Notice the method here. The batch update evicts the cache, or so it would seem if you're new to Spring. If we'll do that and check the bug again, we'll see the cache wasn't evicted. The reason for this is that Spring only reads the annotation when they're invoked from a different class by default. This is one of those gotchas that often fail developers new to Spring. Yeah, I totally didn't see that one. This was relatively simple in terms of observability. Let's up the ante a bit and talk about user-specific problems. So here I have a problem with a trending request. One specific user is complaining that the trending list on his machine doesn't match the trending list for his peers. The problem is that if I put a snapshot, I'll get a lot of noise because there are many users reloading all the time. So a solution is to use conditional snapshots, just like you can with a regular debugger. Notice that you can define a condition for a log and a metric as well. This is one of the key features of continuous observability. I add a new snapshot, and in it I have an option to define quite a lot of things. I won't even discuss the advanced version of the dialog in this session. This is a really trivial condition. we already have a simple security utility class that I can use to query the current user ID. So I just make use of that and compare the response to the ID of the user that's experiencing a problem. Notice I use the fully qualified name of the class. I could have just written security, and it's very possible that it would have worked, but it isn't guaranteed. Names can clash on the agent, and the agent side isn't aware of all the things that we have in the IDE. As such, it's often a good practice to be more specific. After pressing OK, we see a special version of the snapshot with a question mark on it. This indicates that this action has a condition on it. Now it's just a waiting game for the user to hit that snapshot. This is the point where you can just go make yourself a cup of coffee, or just even go home and check it out the next day. That's the beauty, again, of this sort of instrumentation. In this case, I won't make you wait too long. The snapshot gets hit by the right user despite other users coming in. This is a specific request from the right user ID. We can now review the stack information and fix a user-specific bug. The next thing I want to talk about is metrics. APMs give us large-scale performance information, but they don't tell us fine-grained details. Here we can count the number of times a line of code was reached using a counter. We can even use a condition to qualify that. So we can do something like count the number of times a specific user reached that line of code. We also have a method duration, which tells us how long a method took to execute. We can even measure the time it takes to perform a code block using a TikTok. That lets us narrow down performance impact of a larger method to a specific problematic segment. In this case, I'll just use method duration. Measurements typically have a name under which we can pipe them or log them. So I'll just give this method duration a clear name. In this case, I'm just printing it out to the console, but all of these measurements can be piped to statsd and Prometheus. I'm pretty awful at DevOps, so I don't really want to demo that in this case, but it does work so if you know how to use these tools, if you're good at DevOps, unlike, well, me. As you can see, the duration information is now piped into the logs and provides us some information on the current performance of the method. If I had more time, I'd talk about scaling this further with tools like Airflow, Python, or Spark and Scala, etc. These are amazing cases where continuous observability really shines, but we need to wrap things up. So in closing, I'd like to go over some of the things we discussed here and a few of the things we didn't have time for. Lightrun supports JVM languages like Java, Kotlin, Scala, etc. It supports Node for both JavaScript and TypeScript code, and Python, even complex stuff like Airflow. We're working hard on adding additional platforms and are doing that really fast. So if you want a new platform I didn't mention, here just write to me and I'll connect you to the product team. Maybe you can become a beta tester, etc. It would be great to see you. When we add actions and conditions, conditions run within a sandbox so they don't take up CPU or crash the system. This all happens without networking, so something like a networking hiccup won't crash the server. Security is especially crucial with solutions like Lightrun. One of the core concepts is that of PII reduction, which allows you to remove stuff that's confidential, like credit card numbers and things like that, so they don't get into the log and don't cost you in liability. You can also use block lists to prevent users from debugging specific files and doing all sorts of damages. Finally, the footprint of Lightrun is very light, as I mentioned before, and it's very environment agnostic. It works with everything, obviously, with Nomad, with Kubernetes, with AWS, with serverless, with pretty much everything. Thanks for bearing with me. I hope you enjoyed this presentation. Please feel free to ask any questions, and also feel free to write to me. And also, please check out talktotheduck.dev, where I talk about debugging in depth, and check out lightrun.com, which I think you guys will like a lot. If you have any questions, email me. My email is listed here, and I'll be happy to answer them. Also, check out Debug Agent on Twitter, where I post lots of short videos explaining lots of things, which I hope you'll enjoy too. Thank you again.